Okay, hello everybody. Back to the finale of chapter 1 here of our counting methods. And so far in the chapter, we've learned what a sample space is and a list of all the possible outcomes. And we learned that it's often very difficult to learn how to or determine how to count all of the outcomes. And we've actually had 3 methods in this chapter of learning how to determine the size of the sample space. And I've listed those 3 counting methods again here. The fundamental counting principle, the one that says all you need to do is multiply the number of options together for each stage of the event and you get the total sample size. We've also counted with permutations. We know our symbol for permutations looks like that. And then we have our combination counting method too. So the big question now becomes, how do I know what's going to determine which method I use to count? And that's what I want to summarize in this video. So I would strongly suggest for you to try to copy this down, flow chart down in your notes, and or try to memorize this thing. And this will, I mean, it's almost bulletproof, maybe 99% of the time this is accurate. But if you're trying to determine whether to count with fundamental counting principle, permutations, or combinations, follow this flow chart. So the very first thing you ask yourself, and you can see it here, the first question is, are repeats allowed? Is repetition okay? In other words, if I've chosen Annie, can I choose Annie again? If I've used a 7, can I use a 7 again as a digit? That kind of thing. And if the answer to that question is yes, then what you should do is count with the fundamental counting principle. Fundamental counting principle. You know, the one that says just multiply. That's why sometimes in some texts it's called the multiplication counting principle. So if repetition is allowed, flow to the left on the flow chart with a yes and use the fundamental counting principle. If repetition is not allowed, then you flow the other direction and you flow into the second question. And the second question is, does order matter? And then at that point, it should be pretty straightforward. If order matters, you're going to count with permutations. For this video, I'm just going to use the symbol. And if repetition is not allowed and order doesn't matter, then you count with combinations. And so if you ask yourself those 2 questions in the correct order, you'll be able to determine the sample size. So it's pretty nice. Let's give it a try. Here's an example. Ethan's grandma sent him a package of pears for a holiday gift. He was going to grab 2 of the 8 pears to throw into his lunch bag for school. In how many ways can this selection be made? So think of the flow chart. Question number 1. Is repetition allowed? Well, let's see. He's going to grab the pears and throw them in a bag. Can he throw the same pear in the bag twice? No. So repetition is not allowed. And if I think back to my flow chart, if repetition is not allowed, then when I'm going to clean this up, if repetition is not allowed, I'm going this way. So now I ask myself, does order matter? And does the order in which he puts the pears in the bag make any difference? Well, I would argue no again. So this would indicate it's a combination problem. So there's 8 pears altogether, and we want a combination of 2. And so we could use the formula and factorial over r factorial times n minus r factorial. But I'll bet most of you are just going to use your calculator in order to do that. I hope you know how to do that on your calculator now. So I am going to give it a try too. 8 combination 2. My calculator says there's 28 ways that Ethan can throw 2 pairs into his lunch bag. So that's first example. Another example. Well, let's see. Think of the flow chart again. Is repetition allowed? Is the same person going to finish twice? So no, repetition is not allowed. So we flow to the right and ask ourselves question 2. Does order matter? Well, it might not matter to you, but I bet order matters to these 4 guys. And so now we're going to come with permutations. And there's 4 runners, and I want a permutation of, well, I suppose we're going to assume that all 4 finish. So we're going to do 4 permutation 4. And if you do 4 permutation 4 on your calculator, it's going to say there are 24 different ways that those runners can finish the race, the order in which they finish. So that's example 2. Here's another one. I'll let you read it yourself. So it's a little vague in the reading, but do you think repetition is allowed in the password? If I use a W, can a W occur again? I'm assuming it probably can. So let's say repetition is allowed, and that would tell us right away in our flow chart, if repetition is allowed, I'm going to go, whoops, too far. I'm going to go back. If repetition is allowed, if that's a yes, then we're going to count with the fundamental counting principle. So all we're going to resist using the permutation key or the combination key on our calculator, and we're just going to multiply. So let's see, there's 6 characters in the password, and each one is alphanumeric. What in the world does that mean? It's going to split that word right here. Alpha, letter of the alphabet, or numeric, any one of our digits, 0 through 9. So each character can be anything from A to Z, or anything from 0 through 9. So there's 26 options here and 10 more options here. That's 36 possibilities for each character, right? So there's 36 options here, 36 here, 36 here, all the way down. So that's going to be 36 to the 6th power is the number of options here, and that is going to be ginormous. My calculator says 2, 1, 7, 6, 7, 8, 2, 3, 6. Slap a couple commas in there. Oh, that's like over 2 gajillion. So there's a lot of possibilities. It's crazy how fast those possibilities grow. Large bag of candy with 20 Tootsie Rolls and 13 small boxes of Milk Duds. My 2 favorite candies, by the way. Suppose we somewhat randomly grab 4 pieces of candy. In how many ways can we select exactly two of each? Well, let's think about this. Can you pick the same piece of candy twice? So I'm going to say no to that. So then, does order matter? And I don't think it does, because we just need to get 2 of each. So no repetition, order doesn't matter. We're going to come with combinations. Now this one's a little bit more difficult. So how many Tootsie Rolls do we have to choose from? Let's see, there were 20. And I want some combination of 2 of those. And then also for the Milk Duds, let's see, there were 13 of those, how about some combination of 2 of those? So let's do our calculations here. Whoa, why did I put it? What happened to my 2? 20 combination 2. So, oops, having technical difficulties here. 20 combination 2 on my calculator says 190, and 13 combination 2 is 78. Now, the fundamental counting principle says if there's 190 ways to do that and 78 ways to do that, the fundamental counting principles say I need to multiply 190 times 78. And I've got a total product of over 14,000 ways. 14,820. So the flow chart works great, and it's almost, I'm going to skip that example, it's almost foolproof. Here's, we're almost done here, but let's do one more. You can see our master lock here, and we're going to open it. It's your typical 3-number combination to open it. How many options do we have to choose? So, question number 1, is repetition allowed? On a lock like this, is it possible for my combo to be 24, 11, 24? Is that a possibility? I'm going to declare here, yes, that repetition is allowed. So if repetition is allowed, I'm not going to count with permutations or combinations. I'm going to go right to the fundamental counting principle. Now, how many options are there for this very first number? Look at the lock. 0 through 39. How many numbers are there? That's 40 options, right? 0 and 1 through 39. So I've got 40 options. And on the second number here, I still have 40 options because repetition is allowed, and I still have 40 options here. So the fundamental counting principle says, let's do 40 to the 3rd power. 40 to the 3rd power. That's 64,000 possible combinations with a lock that is manufactured like that. 64,000 options. Okay, so again, this is just a review of 3 counting lessons. So do you remember the first question in the flow chart? Question number 1. Think about it. Question number 1 is repeats. Are they allowed or not? And if it's yes, you count with the fundamental counting principle. Question number 2, that's the one that asks about order. Does order matter? If it does, permutations. If it doesn't, count with combinations. So that flow chart is very, very important. That flow chart is what you're going to use to answer all the questions in your assignment. I'm going to skip that screen. I didn't realize it was on there. I'm going to skip that one too. Skip that one. Skip that one. Skip that one. Hey, by the way, let's go back to that one. If you've written down the whole list of all the possible outcomes, what's that list called? Yeah, that's the sample space. Okay, good. All right, so in your assignment, and you'll see it in Schoology, there's an attached worksheet of exercises, and it's a total mix of exercises where sometimes you're going to count with combinations, sometimes permutations, sometimes you're just going to multiply and apply the fundamental counting principle, but you're going to have to decide. So think of the flow chart as you work through each exercise. Give them a shot. We can talk on Google Hangout. See ya.